Hi all, I'm Chongrong Fang. Today I'm going to share our recent work VTrace. This is a joint research work carried out by Zhejiang University and Alibaba Cloud. In the overlay network of cloud computing systems, considering an inter-VPC communication scenario, tenants can configure the virtual forwarding devices like vSwitches and vRouters on their own VPC network, such as ACL configurations. Besides, cloud service providers can also configure or update these VFDs. During these actions, both tenants and cloud service providers can lead to packet losses due to VFD faults or non-VFD faults. These packet loss issues can be roughly classified into persistent and transient packet losses. Here we focus on persistent packet losses, since they are more emergent. When a packet loss happens in the overlay network, for example, here is a non-VFD fault on a vRouter. When tenants sense a problem, they will submit diagnostic requests, which include the information of suspected flows. Then the operations engineers of the cloud service provider will use TCP dump to manually check the VFDs traversed by those flows. As a result, for example, engineers reply that vRoute X is dropping packets, but it works well. Maybe tenants should check their configurations. Such reply is not satisfying to tenants. For more detailed information, the network experts will further check and analyze the root cause. Finally, they find that it is due to the misconfiguration of ACLs. Such root cause is useful to quickly troubleshoot network problems. However, the manual diagnosis is time-consuming. In addition, there are hundreds or even more such diagnostic requests every day. Therefore, an automatic diagnostic system is in need. We call it VTrace. For VTrace, our goals are to quickly locate the culprit VFD and present the root cause for packet loss. To achieve these goals, VTrace should extract the on-site forwarding conditions of packets to reflect the root cause with affordable performance loss. Furthermore, tenants are not required to help implement VTrace. The key challenge of meeting these goals and requirements is how to balance the trade-off between the root cause diagnosis and the low impact on forwarding performance. There is a vast body of prep work related to our research focus. However, they are not sufficient to meet all these requirements. Our VTrace is designed to fully meet the mentioned requirements. To automatically diagnose root causes of persistent packet loss, our solution is mainly composed of three essential steps, that is packet tracing, in-depth processing, and path reconstruction. First, for packet tracing and in-depth processing, a naive idea is to mirror packets and send them to dedicated servers or log systems for further analysis. However, such a design lacks a deep check of packets and cannot figure out the on-site forwarding conditions. So, can VFDs perform an in-depth processing for packets? Actually, the forwarding model of VFDs includes the fast pass and slow pass. The slow pass can be used to process packets in depth. With this capability, we deploy many debug probes in the VFD slow pass to extract the on-site forwarding condition of packets. In production, we have deployed more than 400 debug probes to cover possible packet losses. However, such deep processing is resource extensive for perfect processing, which is not acceptable. We must balance the trade-off between root cause diagnosis and performance loss. As this work concerns the persistent packet loss, checking a subset of target packets may be enough for the root cause diagnosis. According to our deployment experience, usually checking tens to hundreds of target packets are enough. In this way, the forwarding performance can be efficiently reduced. But how can we realize such flexible tracing and in-depth processing? Specifically, for the first hop VFD, the controller tells it the number of packets to be traced with the parameter packet count. Once the target packet comes and the packet count is not reached, VFD will mark the packet through its DHCP value, and then perform the deep check by debug probes. At last, VFD will log the node information and root causes to a local log agent. The log includes necessary metrics such as file tuple, root cause, and so on, which are useful for the later path reconstruction. For the following VFDs, they will perform the deep processing for packets with the mark to get on-site causes, and then record this information into logs. It should be noted that such a design leverages the basic functionality of VFDs and only occupies a small fraction of flow table. With these logs generated, the next step is to reconstruct the path of packets. A useful solution for path reconstruction is to sort these logs with network topology. However, the overlay network topology is complex and dynamic. Besides, the network topology may not be available sometimes. Hence, this solution is sufficient but not necessary. And grouping by packet ID and sorting by time is not sufficient, since the clocks of different servers are out of synchronization. In VTrace, it performs the path reconstruction based on the information contained in the log data, such as the mark for the ingress of the first VFD, the information of servers where virtual forwarding devices work. We conduct several tests on vRouters and vSwitches. The setup of both VFDs is the same as the production one. For vRouters, we found that there is almost no drop in the forwarding rate for packets over 256 bytes, and for packets smaller than 128 bytes, there is at most a 12% drop in the forwarding rate. It is acceptable for small packets, and packets in the business traffic usually have a packet size larger than 256 bytes. For vSwitches, we also found that there is at most 1% drop in the forwarding rate only, which means that the impact of VTrace on forwarding rate is acceptable. Now, with VTrace, once a diagnostic request comes, tenants will get a quick and useful feedback in a few minutes. Then, is VTrace deployable? The answer is yes. We have deployed VTrace in Alibaba Cloud for over 20 months. During the deployment, we get some interesting findings through the usage of VTrace. First, according to this figure, we found that most of the diagnostic requests are false positives. Only a few of them do have a packet loss issue. Besides, it can be seen that there is a surge in the number of VTrace being called. This is because there are some online shopping carnivals from the early September to the end of December. Hence, tenants will expand their cloud resources and conduct pressure tests to meet the upcoming huge business. As a result, these tenant-related operations will lead to the increase of VTrace tasks and packet loss issues. Another finding is that non-VF defaults are usually more common than VF defaults. This is because that VF defaults can be well avoided through software tests before deployment. Further, we collect the root causes for non-VF defaults and then classify them into 5 types. The proportion of each type is provided. Interestingly, it can be seen that vSwitches are more error-prone than vRouters. And we also found that the causes like tenant security policy blocking and tenant configuration error are the major reasons for the packet loss. Also, there are unknown causes, which indicate the necessity of maintaining and updating the repository or debug probes. This work demonstrates the effectiveness of the covering matching and logging idea in automatically diagnosing persistent packet loss issues. Now VTrace has been deployed in Alibaba Cloud, which includes more than 30 large data centers, and has been used for more than 10,000 times. In the future, we are going to diagnose transient packet loss in the overlay network. In addition, the integration of troubleshooting the packet jobs in both physical and virtual networks is also an interesting and important problem. This is our presentation. Thank you very much.
Very good. Thank you, Chongrong. While we are waiting for questions to pour in, let me start a discussion. I want to still a little bit understand better. Did you need to put some safeguards to prevent putting too much load on some of your VFDs, or this was never an issue for you?
Yes, can you hear me?
Yes, please.
Okay, thank you. Yes, in our design, engine VTrace task usually only needs to check tens of packets.
Mhm.
And in our evaluation, it is proven to have an affordable impact on the forwarding performance. And currently, VTrace task can only be issued by cloud operations engineers.
Mhm.
So there will not be too much tracing load on some VFDs now. But however, in the future, if the VTrace APIs are open to tenants, we may encounter this problem. Then, as VTrace is an on-demand tool, we can overcome this problem by limiting the number of VTrace tasks at the same time to, yes, I think, so hope that I have answered the question.
Right, right. Yes, thank you. Question from audience. Minlan is asking, well, most diagnostic queries are false positives. And the question is, do you have any insights on why these false positives happen and what are the root causes?
Okay, in my understanding, those false positives of VTrace tasks is most of these VTrace tasks, VTrace diagnostic requests, it comes from the tenants. Uh, Actually, they do not understand the network well. They will sometimes um, they think they have a network program, but in when we use VTrace, it returns the result returns the network is good, because sometimes the package jobs is because of uh, uh, the sorry there's a false positives, and the root causes for those false positives are, I think that is because uh, sometimes they are
Let's take it one step at a time. How many
okay, thank you.
do you think roughly you have root caused with VTrace?
Sorry,
How many issues do you think you have root caused? Say hundreds of issues?
how many issues
Yeah,
for these switches?
yes.
Mm, uh, it
Let's
depends.
let's say
Sorry.
100, or maybe you have a more precise answer.
The true issues for VTrace uh, is not clear now, but during our statistics, our data collection in 1 year, it has about maybe hundreds of.
Hundreds, yeah, yeah. So maybe some of them weren't really correct. Some of them are false positives. And I think the question is trying to sort of understand what happens when there's a false positive, what happens when you couldn't even find an issue with VTrace. And so that's sort of the core challenge of these diagnostic systems. If you have some high level thoughts, that would be great if you could share with us.
Mm,
Or we can take it offline if you go back to the Slack channel. There's another question from Benoit. Do you have any cases where automatic diagnostics failed and there were experts who had to make a second pass? And if yes, what was the type of these issues?
yes, as we have indicated in the video, there are still some unknown causes.
Mhm.
So that is which tell us there is a packet loss, but it doesn't know why the packet loss happens. This is because we don't these problems are not covered by the debug probes deployed. So to overcome this issue, we are still maintaining and updating the repository of debug probes.
Mm-hmm, mm-hmm.
And for yes, okay.
Please go ahead if you have anything.
That's okay. Thank you.
Okay, great, thank you. Please go back to the Slack channel if you have any further comments about the false positive question. That would be great if you can answer it through the Slack channel.
Okay, so thanks a lot for the talk. We already have a question on the Slack from Wei that is asking that the following question. So in the past, we already have a lot of tools to detect faults or misbehavior on the physical network. For instance, your tool focus on the virtual network. What are the differences? And in a sense, what is unique of the virtual network debugging that we couldn't do with the traditional tools for physical network debugging?
Okay, thanks for the question. In VTrace, our goal is to obtain the culprit device and the root cause when a packet loss happens in the VNet here. And we have found that most of works focus on physical network only can find the culprit device, but cannot figure out the root cause for the packet loss, namely why the packet is dropping here. So VTrace, the main focus of VTrace is to figure the root cause. And the challenges in the virtual network is that the network topology in the early network is dynamic and complex because the VMs are creating and destroying frequently, so the topology is dynamic. And there are many tenants in the cloud network, so it is very complex. So for operations engineers, it is hard to determine the flow path of our target packets. So this is a challenge. And another challenge is that in the overlay network, the root cause for the packet loss is various. For example, those root cause can both tenants and the cloud service providers can lead to packet loss because both of them can configure the vSwitches and the vRouters. So it is very challenging to automatically diagnose the root cause of packet loss. And in terms of the opportunity of network diagnosis in VNet, in my understanding, we have used the DSCP value to mark the target packets we have to check. And this DSCP value can be also used in the physical network. So we think VTrace can be expanded if we can integrate VTrace with the physical tracing tools. By both of them can use the DSCP value to check the same target packet.